everyone, in this video we will be writing polynomial function given 4 complex roots. Before we go over this example that we have right here, let's have a review on zeros or roots of polynomial function. Zeros or roots of a function are values of x that causes the function to be equal to 0. Now, there are some notations how roots are written in some problems. So in some problems, they write it this way. The roots are 5, -3, 2i, 3 plus minus I. In some problems as well, they write it differently. So they write like x is equal to 5. They also write this as x is equal to -3, x is equal to 2i, and x is equal to 3 plus I. And then this is also the other one, since it's plus and minus, so that would also be x is equal to 3 minus I. Now, if we want to change these roots here into its factored form, we are going to use the zero product property backwards. So we can go ahead and rewrite this as x minus 5 in parentheses, which means that if we equal this to 0, then we add 5 from both sides plus 5 from both sides. That's how we got x is equal to 5. So pretty much we switch the sign of this, and that would be in factored form. So in this next root right here, we can go ahead and write this as x plus 3. And this one right here can be written as x minus 2i. And this one right here in factored form, we can write this as x minus 3 plus I. And then that's the other one here is x minus 3 minus I. So this is how we change the roots into its factored form. So pretty much the trick is, if we are given the roots in either of these notation, all we need to do is to switch the sign of the root, put it next to the x, and put these two binomial inside the parentheses. Okay, going back to the examples right here, write the polynomial function whose roots are 2 plus I and -1 plus 3i. So others are going to ask, why is it that there are 4 complex roots when there are only 2 given complex roots right here? We remember the complex conjugate root theorem. This theorem states that if a plus bi is a root of a polynomial, then its complex conjugate a minus bi is also a root of a polynomial. So in this case right here, the first root that we're gonna have would be x is equal to, that's gonna be 2 plus I. And again, please remember that its conjugate is also a root. So that means the second root right here would be x is equal to, that's gonna be 2 minus I. Again, to get the conjugate, you just have to switch the sign of the bi part. So positive, I switched it to negative. And so determining the other 2 roots right here, we can go ahead and write as x is equal to -1 plus 3i. And then we get the conjugate. So this is a positive 3i. So that means the negative 3i is also a root of this function. So that would be x is equal to -1 minus 3i. So we're going to write this in factored form. So this would come out. So the rule is you switch and keep the sign of this. So this would come out x minus 2 plus I. And then this one switch and keep. So this would come out x minus 2 minus I. And this one again is a switch and keep. So this would come out. That's going to be x plus 1 plus 3i. And then this one right here is to switch and keep. So that means it's going to come out x plus 1 minus 3i. So what are we going to do next is we multiply 2 at a time. So I'm going to multiply this first 2 right here. So as you can see, we're going to use a 3 by 3 box in order that we can multiply these 2. So I'm going to show the work up here. Okay, so what are we going to put here would be these ones, these terms. So this is going to be x minus 2, and then this is I. So I do the rest of the other one on the vertical side right here. So that's x -2 and -I. So then we are going to multiply this. So x times x would be x squared. this is negative 2x negative xi, and this is negative 2x positive 4. This is a positive 2i because you have a negative and a negative. This is a positive xi. This is a negative 2i. And this is a negative I squared. So then we go ahead and cross these two out. Since they're opposites, these two will get crossed out too. So if you add 2i plus negative 2i would be 0. So I crossed that out. And we remember that these two are like terms. So then we can go ahead and simplify this as x squared. That's the first one. And then that's minus 4x plus 4 minus I squared. So these are the leftovers since I crossed out these two already. So then we remember that I squared is equal to negative 1. So I'm going to plug it in there. So x squared minus 4x plus 4 minus. And then again, the I squared is negative 1. So then this would come out x squared minus 4x plus 4 plus 1, because you have a negative of a negative is a positive 1. So then the final answer for this would be x squared minus 4x plus 5. So this first two right here will come out x squared minus 4x plus 5. So I multiply them together. Now the next thing that I would do is to multiply these next two right here using the same process that we did here using a 3x3 box. Okay, so what I did was I crossed out this one. So as you can see, these boxes will always get crossed out when we are multiplying these two factors. So then these boxes gets crossed out. So the leftover here would be x squared plus, that's gonna be 2x plus 1, and then that's a minus 9i squared. Again, we remember I squared is equal to negative 1. So then I am going to simplify this. Okay, so when we simplified it, it came out to be x squared plus 2x plus 10. So I'm going to write that up here. So this becomes x squared plus 2x plus 10. Now, what are we going to do next is we multiply these two together. So it's going to be, again, another 3x3 box. Then I'm going to show the work down here. Now we remember that these are like terms here. They're all raised to the power 3. These 3 are like terms raised to the power 2. And these 2 are like terms raised to the power 1. So then we can go ahead and write the function here, or the polynomial function f of x would be equal to, that's going to be x to the 4th. And then we have 2x cubed plus negative 4x cubed is a negative 2x cubed. And then we have 10x squared minus 8x squared plus 5x squared is a positive 7x squared. And this is negative 40x plus 10x is a negative 30x. And then we have a plus 50. So this is the polynomial function that has 4 complex roots, and the roots of this polynomial function are these, or these right here. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!